Thanks, everyone. So we wanted to do two things. One, we wanted to describe where some of what Cisco had done in the past, and probably even some of yourselves may have done this in the past as far as development of applications that we'll say ran in the cloud. And then we want to showcase a setup that we have currently in Amazon and talk about things that we had learned around that and problems and flexibilities of that system and how it can help you, say, deploy applications and your services to the cloud. So first, let's start with where we were probably about 8 years ago when I first had went into Cisco Services. I've been in Cisco myself for 19 years now. Um, at that time, what they did was most applications went through a load balancer, and they would pair up pairs of WebSphere. So all applications were a Java application bundled in an ear. For some people, this may be words you've only heard about, and you may have not have ever done it. Um, the thinking there was that Cisco's website was going to be more of a portal, and each thing would be a portlet, and it would show up in different parts of the screen, and they were going to even let people configure it. And there was this time in the past where there was My Yahoo and My Cisco and so on and so on. Well, pretty much everybody's figured out that no one really customizes their web pages. They just go to them and use them and hope that it gives them everything they want. So what they would do in this kind of setup was it wasn't like I had four versions of my application running. What they did was they would split up the load based on the API. So they would measure each one and say, okay, these 5 APIs use this amount of CPU, and the other 4 use the same amount of CPU. And they would go to the load balancer, and it was pretty much of an API gateway, and they would route the 5 to the one pair to have HA, and then the other 4 to the other pair. And if you ever started getting into more load, or you had more APIs and it was more than you needed, they could double these out. So they would add more pairs to help handle the load. But most of these applications at the time were built using the standard, JSPs and everything. So every get, put, and so on was a full, all the way back to the server, web page rendering. Nowadays, of course, a lot of people, us as well, are doing single-paged applications. So you're completely divorcing the UI from the back end, of course. And so what we want to talk about today is really what we've done in the back end. There's a little bit about the front end here. So here's kind of the architecture we have today. This is Amazon-centric. This is where our cluster lives today. I didn't draw every line here, so I tried to just draw a few lines just to show how some information's flowing, some key things that I wanted to point out. Clearly, if I drew all the lines and everything that could be here, it would be so messy that we wouldn't be able to see anything. So what we're starting with at the top, and I don't think I get a mouse, the website, your web page comes in, of course, as you know, and asks for data on 80 or 443. Hopefully the 80 always automatically redirects. That's a huge security thing you want to do. Also, there's a header that they tell you that you should add when you get into there, which is the HSTS header, which says you should only come in on secure sockets. So please don't ever come to me again on HTTP. But you have it open because otherwise, if someone did type in HTTP, yourcompany.com, and you're not listening to at least redirect them, or they would get a blank page, and that's not what you want. With Amazon, you can come into CloudFront. CloudFront will serve up your static content. You can enable that for edge locations around the world. So there's about 180 edge locations, which means that everybody, no matter what part of the world they are in, are going to get your web content nice and fast. CloudFront can service data from S3. It can also service it from other things. So you can use CloudFront to receive your web service calls and your web content calls. And one of the things we had done, we actually separated those out. So we had a prefix kind of algorithm where we said if it's /WC, which meant web content, that would go to CloudFront or S3. If it came in WS, we used that as a web service route, and then we would route that through the application load balancer into our Kubernetes cluster. And that's what everything on the right is. Why did we do that? Well, we did that so that at the CloudFront or at an Nginx level, we can control the cache headers. Because you don't want web data that is, coming from a database. You do not want it cached anywhere in the system. Not in your system, not in the browser, or any proxies that could be in between. Whereas web content, you almost really want to set it up to be cached forever. And so what we did there was we tag our web content with a time date stamp or a SHA or something, because now what you can tell the browser is this piece of data can be cached forever. It's never going to change, because when you redeploy or you update something, you'll update the SHA and you'll update what SHA the application is looking for from the web URL. Now your index.html, of course, unless it's very fixed, you're going to want that to be something where maybe they cache it for a day or whatever your release cycle is. If you're only updating index.html, say every 2 weeks, you may set it for a week, and that way the browser still doesn't come back and get it from, say, Amazon. The way the CloudFront works is when it goes to S3 is anything that it gets back actually gets routed through Lambda. Lambda is where you're going to add those headers, like the HSTS header, any kind of other headers that you want, you can add them in Lambda. They don't give you that capability in CloudFront. And then one other key feature, which we'll get into with the security, is the WAF, which is the Web Application Firewall. One of the things that Amazon can do is if anybody's hitting your system and issuing too many 404 requests, 403s, even 500 errors, the WAF system will actually block their client IP for a certain amount of time. And that's a huge security thing that security engineers want you to do, because someone could do a denial of service. And so Amazon is trying to help you here. If it does come in through a web service call, the load balancer will be called, and then we'll route it into our Kubernetes cluster. And the way that we set it up is we have Nginx. We have more than one, of course, so we have HA, but we route the request through Nginx, and we use a route pattern then to route it to the right microservice. So we have built a full microservice architecture so that services call other services, and each service owns its own data. And those services will write that data either to Redis or to Mongo, which we have a 3-node Mongo cluster. What that allows us to do is, sort of separate out different things. We use Redis basically for web tokens or session tokens. We run our system as an OAuth 2 implementation, and so that is what that will contain. Whereas all static data or all data that is customer data will be written to Mongo. Let me see. So one of the other things that I wanted to call out is that we didn't initially buy into everything that Amazon had to offer. And the reason we did that for our architecture was we weren't sure if at some point we'd have to move it. If we had to pick it up and lift it to, say, Azure, or pick it up and lift it back into Cisco, what we could take is the core Kubernetes cluster, get all those services and everything there, back into whatever data center we were going to go to or whatever cloud provider we were moving to, and then we would just have to update our system for the whatever web content. So like Cisco would use Akamai, as Azure you'd be using Azure. One other thing around the architecture that we have is we have config maps and secrets in Kubernetes to help with our microservices so that they are hopefully not specific to the environment. So therefore we load in those pieces of information right into the cluster, so they go right into the service. That also, those secrets you want to control so that if they have generic ID passwords that maybe talk to other systems and you can't share with a client, or you don't want to share with certain SREs, you want to control those in a manner, and you would set up your Kubernetes to have RBAC so that you can also control what people can do. So let's talk about security for a moment. So one of the things we did was our VPC, our virtual private cloud that we set up in Amazon, is it has 2 open ports that are for web traffic, and that was the 8443. The other one is our VPN gateway. The only way that anyone can touch any of the nodes underneath is to go through that VPN gateway, and that list of people is managed by our SREs. So we limit right now how many people can actually get into the system to debug it, how many people can get in to deploy code. And in each of those nodes, each have a key for those individual users. So we can actually differentiate people that can talk to Mongo versus the people that can talk to Graylog or talk to the nodes. So SREs that might be messing with Kubernetes will have their keys on the Kubernetes nodes, whereas maybe our normal engineers that are doing DevOps may have access to Mongo so that they can get in there and solve problems. And then they can, of course, go to Graylog to further see that. Some other things that you want to do around security is like least privileges, right? So you want to make sure that you have groups of people. You set it up so that if it's a person that's only support, maybe they're supposed to go in and check logs, or maybe need to reboot something, or scale. Maybe you're not doing auto scaling at the time, and your system is fairly stable, your client load is fairly stable. So therefore, as the load goes up, you say, I want to add another instance of a microservice. Then you would give that to, say, a support engineer. Your SREs are probably going to have a full set of support. Your developers, you may say, cannot even deploy code, right? Maybe they can go in and do a little bit more information or operations. But one thing that we would suggest you do is have like a CD pipeline that would actually deploy the code. And a good reason for that is not so much that it's automated, because you could have a button that someone logs into a website to do it, but then you get logging, you know what people have done, they haven't edited the code directly. You could then restrict like pushes of your microservice Docker images to ECR, so that only that machine can do it. And what that gives you is repeatability, and also gives you logging of who did deploy the code and when. Kubernetes gives you some of that. FluentD can be used to grab those Kubernetes logs. It's used to grab the microservice logs. But if you can restrict who actually gets into the cluster, the security experts really love that. Another thing that we do is we log at the VPN gateway the access. We also log when people run commands against Kubernetes, and we do that so that the SREs can see what people are doing. So that way you know if someone went in and where they were just debugging or were they trying to deploy code. So these are kind of things that security experts are going to ask you to have within your cluster. So one of the things that you run into with security as well is the way we set up our system, like I said, is an OAuth 2 system. So people come to our OAuth 2 microservice to get a bearer token. They then can call APIs. But if you have a single page application and you want to provide any kind of download, a lot of download links, if you're not using the actual download HTML attribute, and if the browser supports it, not all of them do, you end up with an URL that really will only work if you have a cookie. So you're going to have to kind of solve that, and there's a couple ways you can do that. And that would be to encode the link to have data that's encrypted that only your system can decrypt, but that would determine who can get the data and what data they're supposed to get. Or you could, whenever they load a page that could have a download, you could set a cookie, have a short lifetime on it, and then when they download, then after that you could delete the cookie. Let's see. So one of the things, like I said, we're using FluentD to grab all the logs. One issue with that is that when you have Docker containers and you're logging the standard out, which makes it nice because then you don't have to do anything special. You don't need to worry about having loggers that are able to keep up with receiving your flow of traffic, because FluentD will grab that. But one of the things you have to do then is, as Docker, as you write to the file system, that creates a layer. And that layer can fill up, and you can actually fill up your varlib Docker on your Unix machine. You can, and so then the machine actually becomes unusable. So one of the things that we do is, as we're grabbing the FluentD logs, we'll actually clear the logs just the way you would normally in a Linux system. So that way, because you don't need them there anymore once you've grabbed them. The other thing that we suggest you do is actually with your microservices, if you have enough power to do it, you would actually log everything at debug level. But what you would do is you would actually send those logs to two different ingestion systems. And one ingestion system would take the debug logs and everything else that comes with it and say keep it for 2 or 3 days. It's got a very limited lifetime. But that way you don't need debug logs until you need them. And usually when you run a system and you say, hey, I'm only going to log, say, warning or minor and above, or and worse, then that means that when there's a problem, there's nothing to really usually go back and see what's going on. If you have a debug log that's, say, 2 or 3 days old and that's it, now if someone reports a problem today, you can probably still find it. If it was yesterday, you still can find it. Now, of course, if they don't report it until a week later, that data's gone and we need to wait for them to have a problem again. But then you run into, I need to keep data. So one of the things that you run into with security is that you need to have data retention. That data retention sometimes could be 30 days, it could be 180, it could be a lot more when you get into financial systems and everything else. So that's why you don't want that system to have debug, and you would actually filter out the debug logs in the general retention system. one of the things that another thing under security too is that user IDs, as you're logging, you got user IDs, maybe addresses and other stuff. You should make sure you hash that data. You do not want your logs to have those pieces of information, because then if someone would take the logs, they now have extra data, maybe PII, that could be very, putting those multiple pieces together could help them maybe hack someone or pretend to be them or whatever. So the least information you can give, the better. Let's see, sorry. So one of the things that too with the architecture like this that you could possibly do, and our Mongo's outside of the cluster, ECR of course is outside, would be to do a green-blue install. Now you could spin up a whole new cluster, because Kubernetes is like being on a treadmill. As they are developing new versions and everything, they're deprecating old configuration options, they're asking you to do new configuration options, and sometimes your configurations that you need for one version to the next can completely change. And that can take time, or it could be I just always restart from the base Kubernetes and only apply a certain amount of configuration to disable things or to set it up for my cluster. So one option would be is to fire up a whole new cluster, because it should be there for a short amount of time, and basically replay all your YAMLs to get all your services inside of there. They're going to, of course, connect to Mongo, and now you could actually test it and make sure that everything's working. And then once it is, you basically would just remap your application load balancer to point to the new cluster, and you could shut the old one down. And that way you're not wasting money having multiple clusters up. Another thing is applications, as you know, as you deploy them to Kubernetes, there's a couple ways you can do it. You can also do those in a blue-green, so those could be versioned in a way that the name of the service or the name of the deployment has a version in it, so that when I deploy a new version, I get a whole new one, and then I can remap the service when I'm ready. Another thing that you can use, and we were talking about a minute ago, is applications like Kong and some others where they may create sidecars in every one of your deployments so that you can encrypt data. You can control which services can talk to other services, and that can be important if you're trying to do true isolation of application or your multi-tenant, because Kubernetes doesn't really support multi-tenant all that well, right? You can do multiple user roles in RBAC, you can do namespaces, but there's nothing to prevent one namespace from talking to another namespace. And so sometimes you need things like Kong or whatever that set up a configuration layer beside your system so that you can control that, and then you would have that configuration controlled by the proper people. Let's see. Just trying to think if there's anything else. Let me ask if there's any questions right now based on what I've said so far.
Yes, there is actually one question on Slido. Any specific impressions about Greylog compared to other log collectors, and why you stop using that?
Good question. So right now, some of these things we're letting to be controlled by our SREs, and Greylog they're comfortable with. I am never tied to any one, say, technology, so we clearly could replace it if there's a better. We have had some issues with it, because Greylog using Elasticsearch, one of my colleagues is over there hiding in the corner actually, and they've had a lot of issues with Elasticsearch and keeping it up and running and accepting the load that your microservices are debugging at. So yes, that can actually be an issue. We just haven't quite looked at any of the others. One of the things is our group is somewhat small, so as a lot of small groups, it's hard to keep up with some of the technologies. And so we have to kind of keep everything running and investigate, and if there's something better, we will move to it. Also, we're bringing in some other people that have some other experiences. The couple guys that were in here before have some other experiences with Kubernetes and cloud, and they are also helping figure out some of those technologies.
Mm-hmm. Any other questions from the audience? Okay, so what your infrastructure as code tools basically approach? What's your choice? Do you use AWS native approach with CloudFormation, or would you prefer Terraform, Ansible?
So right now, our SREs are using Ansible. Again, that's another thing where they're comfortable with. We have talked to them about Terraform or even using Helm charts to deploy our applications. Today, when we actually build everything, and some of this is history, so some of it's just like how we had done things prior to even Kubernetes really being there. So prior to this deployment, we used a system called Staccato, which was a paid service on top of Cloud Foundry. And that actually wasn't very stable. I know Cloud Foundry is still out there. I think it's actually owned by HPE, but we had a lot of issues with it, and it would crash once a month, and usually it meant a full cluster reboot. So some of the things that we had to do for it, we had created tools. So today we have a couple build tools that create YAMLs, create the Docker images, push them to ECR, but there's no reason why we couldn't change those and say switch to Helm charts and everything. And we are evaluating that. And and from my standpoint, one of the things that I have to do, like as an architect, because I have a team of people doing things, is evaluating the technologies to see, does it make sense? How much do they have to learn it? If they don't know it yet, then if we switch this to a technology and then the one person that does know it goes on vacation and something happens. So we have to make sure that everybody's, or the majority of the people are in sync on what that technology is going to be and everything. We do a lot of this with Node. One other thing I wanted to mention around security too. So one other key thing is, especially with Node and NPM, but this is true of the other things, is you want to know what packages you're using, if they have any security flaws. So they're issuing CVEs all the time. When you run your CI/CD and you're building your, say, microservice out of Node or Scala or whatever, you should have a phase of that pipeline that is doing an audit, making sure that none of your existing packages that you're pulling in have a huge security flaw, at least that's been notified. At Cisco, we actually have a system already built in, and maybe some of your companies do too, but we have a system called IP Central. So everything that we push out to the world, we have to register all of our open source, and they actually notify us when there's been a CVE created against any of those packages. If you don't have that, what that means though is you need something that every so often takes one of those Docker images that's currently running and maybe going to run for the next 6 months and rerun the CI pipeline against it, at least the audit part, to make sure I don't have an existing flaw in one of those tools. That being said though, one of the things that you, with a setup, say, similar to this, where you're coming through a load balancer, coming into Kubernetes, and your services are not directly exposed to the outside world, that helps with the security. So maybe they tell you that if someone has access to the node and they do this regular expression, node will crash or it'll leak something. Well, in this case, the only way that they actually hit the node microservice is through a web service call that's balanced through CloudFront, through an ALB, all the way through Nginx into it. So someone actually can't touch the node. And because also you had to have a key to get to the node, you had a key to get through the VPN gateway. So there we kind of isolated things. So some of those concerns can be nullified, but you do want to run those CI scans, those audits of your packages routinely so that you fix anything that could be major.
By the way, do you actively scan your workloads, or is it done during the build process? For example, during the Docker build?
Right. So today we do it during the Docker build. And again, like I was saying, since we have the IP Central system within Cisco, as we deploy, we can register the open source versions that we're using. So they notify us. So we, in our case, we don't have to constantly scan them. We probably will put something in anyway in the future so that we can know, but they also notify us. So that kind of, for us, shifts a little bit of the burden to a central system. Because Cisco is a company of many business units, 70,000 some employees, if not more. And so there's a lot of projects, and so they've built a lot of tools to help each of these teams not have to do this on their own.
Okay.
Yes, absolutely. So thank you. Very good question. So within our systems too, Cisco enforces that we do scans, and we'd already done this. When we built our system, we started out with already knowing to have session tokens and to encrypt the data, and you're validating it, and making sure that someone can't do something and that a piece of code doesn't make an assumption of like which account it's trying to talk to. And so part of that too, part of the Cisco culture, part of the Cisco process of even deploying code out to the production world is we have to do scans of vulnerability scans of our web services. We scan also the web client code just to make sure those. Now those web service scans, you can use something like IBM's App Scan. There's another one out there that you can use, and those basically help you test your web service. And you can do fuzzing where you basically send it junk data to see if your web service is going to crash, because you want to know, like, if someone's out there and they just, for giggles, want to send you a 50 gig file over your web service call, that your system isn't going to crash. You want it to be rejected as soon as possible. Another thing that sometimes that you may want to do is have an API gateway, which we do with our Nginx, which helps limit loads and other things, is that puts the security things that you can do at one point. Now you're going to have n number of those, but a lot of your rules, you can put it in that API gateway so that each application doesn't have to redo everything that you're doing, in your general security. So part of that's based on architecture and how you want to run it. If you're fine with each application doing that, you can do that, but that will mean that you're doing extra workload per microservice, to check things. But you should be doing it somewhere.
Mm-hmm. Do we have any more questions? If no, then thank you again. Thank you, Scott, for your presentation. Please give him a warm applause.
Thank you.